Hey everyone, welcome to the Being Patient podcast. I'm Deborah Kahn, founder of Being Patient. When my mom was diagnosed with Alzheimer's disease, I decided to use my skills as a journalist in a different way. Frustrated by the lack of information on science and the inability to get different expert opinions, I decided to quit my job at the Wall Street Journal to create a better platform for people impacted by dementia. We are a community where news and information is created by our team of journalists. We ask tough questions and we simplify the science so that anyone can understand. We don't only cover disease, but delve into the latest research on what it takes to keep our brains healthy. We invite the experts and ask your questions. Here's today's podcast. I hope you enjoy it. Hello, everyone. Welcome to Being Patient Brain Talks. I'm Deborah Kahn, founder of Being Patient. Well, for those of you who listen in on these interviews, you know that I'm really fascinated with technology and how technology is really changing the way that we look at our brains and understand our brains for that matter. So today we have joining us Dr. Andrei Irimia. He's from USC. He's a quantitative neuroscientist, gerontologist, and biomedical engineer. Thank you so much, Dr. Irimia, for joining us.
Thank you, and thank you for having me.
Okay, let's start about, I have been told, or I've read in various places, that we really only know like 1% we really understand about 1% of how the brain works, of what there is to know. Is that true? Do we really know so little about the brain in terms of understanding how it works, how it ages, everything?
Well, it's interesting because there's been such tremendous progress in the past few decades. And in some ways, we know quite a lot. We know a lot about the organization of the brain. We know about the areas of the brain that are affected by Alzheimer's disease and by aging. And we know a lot about the processes that take place in the brain that give rise to mental health disease or to other neurodegenerative diseases. But you're right, there is a lot that remains to be explored and that remains to be discovered. And we're happy to be at that frontier.
Okay, so your lab is really looking at how to use artificial intelligence to really understand how our brains are aging. So let's just back up first and say, I want to hear about the AI, but first, how much can imaging tell us about our brains? I mean, MRIs, there's different ways of imaging from MRIs to PET scans. Not everyone's able to get a PET scan. So let's just talk about that earlier stage. People are a bit worried about their memory. They may be getting a cognitive assessment and an MRI for that matter. What can you see in our brains to tell us how old they are in terms of an image?
So it's quite remarkable that multimodal imaging, so imaging the brain using more than one modality, such as MRI or CT or PET, can reveal a tremendous amount about how our brains are aging. And there's been a lot of research in the past several years and several decades to integrate these techniques and help us to understand how our brains might be aging in ways that can predict our risk for disease. So it's actually quite interesting that with MRI, you can map some very subtle features of the brain that can reveal the extent of atrophy, so the extent of shrinking of certain parts of the brain with some functional techniques like PET and other techniques. You can image the activity of the brain and get insight into whether there are deficits of brain activity that could be reflective of Alzheimer's disease processes. And this is one of the reasons why MRI and PET and these other imaging techniques have really taken hold of the medical field in ways that help clinicians to identify and to diagnose persons with cognitive impairment, including Alzheimer's.
What does an aging brain look like through imaging? Do we all kind of age, as we physically age, we get wrinkles, our hair turns gray. What does an aging brain look like? Does everybody's brain age in the same way?
So in the aging brain, typically we see commonalities across most people. We see a phenomenon called atrophy, which means the shrinking of the brain matter. And we also see something called ventricular enlargement. And the ventricles are these fluid-filled structures in our brains that dilate with age as our brains shrink. So these and other features of brain aging are very apparent throughout most people. However, there are also abnormal patterns of aging that may be seen in mostly persons with disease. So for example, in Alzheimer's disease, we see tremendous changes in a part of the brain called the temporal lobes, where we see a lot of atrophy, a lot of shrinking, and also in the hippocampus, which is a structure in the brain that's responsible and involved in memory formation. So there are patterns in the brain, in the aging brain, that can tell us a lot about the type of disease processes. And this is something that we've been trying to leverage as we developed our approach to estimate brain age.
Okay, so you're now using artificial intelligence to determine how brains are aging. What have you found out?
Well, what we found out is actually quite interesting. First of all, we found that there are different patterns of aging that are quite subtle, that are different in men versus women. So men's and women's brains age somewhat differently. And although there had been research on this before, we were able to identify using our AI approach some patterns that are very subtle and that we could map across the whole brain, and that we could then use to understand these sex differences better. So that's one thing we learned. Another thing we learned is that in Alzheimer's disease, there is, as you know, a difference in risk between men and women in the risk of Alzheimer's. Females are at higher risk for Alzheimer's, and it's not yet clear why. And using this AI tool, again, based on our work to understand differences in brain aging across the sexes, we also noticed that some of these differences are actually based on differences in sex that translate into differences in aging patterns between the sexes that lead to Alzheimer's disease. So it seems that part of the reason Alzheimer's is more frequent in females is perhaps based on the fact that the female brain ages a bit differently from the male brain. So we found that very interesting.
That's really interesting. What did you see when you say they age differently, women age differently than men in terms of their brains? What did that look like?
Well, there is a very interesting phenomenon called laterality in the brain. In other words, certain brain functions are relying more heavily on one side of the brain, say the left side, compared to the right side. And the fact that we are, for example, left-handed or right-handed is based on this kind of laterality. And what we notice is that some of the patterns of aging and differences between men and women are due to this phenomenon of laterality. And for example, what we saw is that the dominant hemisphere, so in other words, the hemisphere that's usually larger in a person, depending on whether they are left-handed or right-handed, is actually atrophying slower in one sex versus the other. The subdominant hemisphere, in other words, the part of the brain that's not being used as much, is actually more vulnerable to aging in men, but not in women. So there is this very interesting laterality effect that seems to be mediated by sex. And so it's a very interesting new finding on the aging of the brain.
So did that mean though that women's brains, their more dominant side would age faster, or it's just their less dominant side didn't age as fast as men's?
It's the latter. So the subdominant uh, hemisphere of the brain will age a bit slower in women than it does in men. So men are a bit more vulnerable to these laterality effects. And if you think of the adage, if you don't use it, you lose it, that applies to the brain as well. And in the case of brain aging, it applies particularly to men because the subdominant hemisphere seems to be aging faster than in females.
Which is counterintuitive to the fact that more women than men get Alzheimer's. So yeah, it's interesting to see. So maybe our brains look like they're aging faster, but that's you can't compare that to cognition. Is that possible?
Well, there are certain functions that we have examined. So we have looked at how the patterns of aging in the brain relate to patterns of cognitive performance. And we found actually that our AI tool was much better able to predict cognitive impairment seen in mild cognitive impairment, for example, and in Alzheimer's disease, much better than the actual chronological age of the person. And so we hope that this tool will be useful in estimating risk for cognitive impairment much earlier than currently possible, because we are relying on identifying patterns of aging, and aging starts very early in our 20s. So then we have a process that takes place across the entire lifespan, and certainly across adulthood. And if we can find these patterns of aging that extend throughout the middle age, that would be a tremendous help in identifying people who might be at higher risk.
So you say we start to age in our 20s. Do all brains, I mean, you use the expression, if you use it, you don't lose it. Do all brains have to age? Is that just inevitable? Is it true when people say, oh, my memory's not as good, or, oh, I'm not as quick as I used to be? Is that true?
As far as we know, aging is a universal phenomenon in mammals, including humans. However, the rate of aging is very much variable from one person to the next. And in fact, that's one of the facts that was of tremendous help to us as we developed this AI tool, because we relied on these differences in the pace of aging across individuals. And we see how interesting it is to look at these differences and to identify the patient-specific profile of aging. And so, for example, with healthy diet and plenty of exercise, the brain ages a bit slower. There are populations out there where, in fact, they're getting so much exercise that their brains age very slowly. On the other hand, there are groups that have brains that age much faster. For example, in alcoholism or drug abuse, the brain is aging much faster. In obesity, the rates of brain shrinking are faster as well.
So when we have conditions like obesity, alcoholism, drug abuse, is that reversible in our brains? Because those are caused not by just our natural biology, but they actually are caused by, for a reason. So can we reverse aging, I guess I'm asking, when in those types of cases?
Well, the brain turns out to have a remarkable capacity for bouncing back. And there's been research suggesting that if these toxic habits are discontinued, the brain can gain some of its previously lost functions and recover to some extent. Now, some of the damage may very well be permanent, depending from looking from case to case. But the brain does have the ability to recover to some extent, and actually, it's larger than we might anticipate. And what we saw in these individuals who have recovered from alcoholism and other similar conditions is that their brains start to atrophy, they start to shrink slower than they did while these individuals were alcoholics. So it's a very interesting phenomenon to map and to understand.
So is the AI tool being used currently, or is it still being researched as to how effective it is to diagnose or to assess brain age?
So currently, this tool is available to the public from a website that's actually listed in the paper that we published, and it's available to researchers and really anyone who would like to try it out. What is needed to use it is a high-quality research-grade MRI scan and some pre-processing. So it's not quite the kind of tool that anyone can use readily, but it is available to other researchers worldwide, and anyone who has the data and time commitment to analyze these brains. And so we made this public so that others can use our tool to learn, gain more insights about the brain. And we're happy to do that.
So does that mean, though, if it's open to the public, and let's say I got an MRI and some sort of checkup, I could upload my results, or do I need to do it through a doctor?
So what would happen is that you would need to download our software, and there is a little bit of expertise needed in learning how to run it, but it's not very difficult for someone with some programming experience, because it's a software package that's it has a programming like interface, but it does take as input the MRI scan with some pre-processing, and then generates a number which is the biological age of the individual whose MRI was uploaded.
So that's fascinating. Does it assign you an age then? Your brain is X years old.
Yes. So it does not know the sex or the age or really anything about the person, and it will usually guess age fairly accurately in persons who are cognitively normal. In individuals who have Parkinson's disease or Alzheimer's disease, it'll actually be off by a number of years, and the difference between the true age and the age predicted by the software is something called an age gap that tells us how much older the brain of that person is than expected for a cognitively normal person of that age. So, for example, if you upload the scan of a 70-year-old who might have Alzheimer's disease, and the software says that person is 75, then that means that the difference, 75 minus 70, those 5 years, is the extent of additional aging in that person that's due to the disease or to other processes. And so this is 5 years, this is a brain that's 5 years older than expected for someone of age 70.
Right. We're getting some questions coming in. This is a good question as well. So you talked about Alzheimer's, Parkinson's. This person is asking, do brains of people affected by childhood trauma seem to be affected more than those who don't have the trauma? How much of the aging that causes Alzheimer's is from environmental factors? Can we determine that through this AI tool?
Well, I think the tool can certainly be used to help studies of that kind. What has been seen, not in our research, but other researchers have found that persons who went through trauma in their childhood are at higher risk for anxiety and depression throughout their lives, and may even be at higher risk for other disorders of the brain. It's unclear that they are at higher risk for Alzheimer's, but this trauma that the question mentions is actually a potential contributor to accelerated aging. We do need to do more research in that area, which we haven't done yet, but it is certainly a compelling hypothesis.
So now that you have a bit of data, how accurate can you say, or can you yet, do you have enough data to say how accurate this AI tool is?
So we're very proud of the fact that actually of all the tools that have been developed to estimate brain age, ours is so far the most accurate. And the average error in persons who are cognitively normal is about 2 years. So plus or minus 2 years is the average error. And so this is the best that one can get so far from MRIs. And we're excited because this is usually much smaller error than needed to quantify aging in persons with Alzheimer's disease, where you have accelerated aging that's considerably more than just the 2 years of our error.
So, Dr. Irimia, can you tell us what the site is? Because I'm sure people will want to know, and we can have my producer Katie can put it into the chat. What is the website?
Sure. So I can bring it up here and post it put it in the chat. I'll just need a minute to open the paper and copy it.
Okay, no problem. And then we can post it in the chat. But as you're talking, I'm thinking about not only diagnosis in that early stage. I mean, for those of us who have loved ones with Alzheimer's, my mom, is entering a later stage of Alzheimer's. Would we be able to understand where she's at within the defined stages of Alzheimer's? Would this help us say, okay, now she's entering stage 6 or 7 according to her brain age?
I think some of that can be mapped using our tool, because the stages of Alzheimer's are related to the extent of additional brain aging that the disease causes. So I do believe there is a relationship between the amount of excessive aging seen according to the stage of Alzheimer's disease. Now, there is also the question of how the brain ages that we predict are related to the cognitive impairment extent and severity of the person. And what our study has shown is actually that we have very good agreement, especially in certain cognitive tests and pertaining to certain aspects of cognition, we have excellent agreement between our predicted brain ages and the stage of Alzheimer's in these individuals. However, we do need to be careful because there is a lot of heterogeneity in this group, and so we do need to do more studies on that. And so we cannot always say with confidence that in any single individuals or that in every single individual the software will capture things as well as on average.
Okay, and I just got that link, and Katie will put it in our talk messages so other people can get it. What about predicting or understanding different types of dementia through this tool? Would that be helpful? I mean, we know misdiagnosis is a huge problem. People are often diagnosed with Alzheimer's when it's not Alzheimer's, it's another type of dementia, Lewy body, for example. Could this help us or help doctors understand really what type of dementia their patients are facing?
I think that for differential diagnosis, this tool is probably not as helpful, partly because we're using MRIs, and from MRIs alone, it is rarely possible to do very accurate differential diagnosis of Alzheimer's versus frontotemporal dementias or dementia with Lewy bodies and so forth. Usually that kind of differential diagnosis has to involve a more comprehensive imaging and medical examination of the patient. So even with all the MRIs we might use to train this neural network, this type of tool is not there yet. However, this is a very interesting question because to do this kind of differential diagnosis using a tool like ours might very well be within the abilities of AI in general. And we're very interested in extending the capability of our software to do this kind of work, but we do need to acquire more data and to have larger data sets to look at before we can say that we can classify patients according to diagnosis.
Dr. Andrei Irimia, thank you so much for joining us. It's fascinating, and we would love it if you find out more. Please let us know. We'd love to hear more. We've posted the link to the site in the chat, or we will if we haven't. And please let us know and keep us abreast of what you're discovering, because we all know as more data means you find out more with artificial intelligence. Thanks very much for joining us today.
And thank you for having me.
So if anyone missed some of this interview, please know we always post on beingpatient.com. And don't forget to subscribe to our newsletters, because within our newsletter, we let you know about upcoming talks like these. Thanks everyone for watching, and we'll see you next time. Thanks again.
Thank you.
Well, I hope you enjoyed today's podcast. For more information on upcoming interviews, don't forget to sign up for our newsletter at beingpatient.com. That's beingpatient.com. And send us any feedback you may have, whether it's someone you want us to interview or any comment about our podcast series. You can do so by emailing info@beingpatient.com. Thanks for listening, everyone. I'm Deborah Kahn.